second half of section 11.4, drawing conclusions from samples. So in the last section, we talked about gathering a sample. Now, as we're doing that, so now we have this sample, and of course, the sample is not always going to be exactly what you're not going to get the outcome that you would have gotten if you had actually surveyed everybody in the whole population. So we have what's called a margin of error. You know that that at some point somebody that answered the survey didn't agree with the majority of people in your population. Now we know though that as you increase your sample size, your margin of error gets smaller. So the more people you ask, the more likely you are to represent exactly the entire population. So there's a formula that of course mathematicians have come up with a formula for this. The margin of error is plus or minus 1 divided by the square root of the number in your sample size. So as this n gets larger and larger and larger, this margin of error, this fraction, actually gets smaller and smaller and smaller. So let's do a couple. In a survey of 1,535 people, 45% of the people that were surveyed preferred brand A of whatever it is, toothpaste. All right. So we want to know, what is the margin of error for this particular survey? Well, the margin of error is going to be plus or minus 1 over the square root of the size of our sample. So we're going to have the margin of error is going to be plus or minus 1 over the square root of the size of our sample, which is 1,535. So you're definitely going to want to use your calculator for these. The square root of 1,535 is, go! Thank you very much, 39.18. Well done. So, and then you take 1 divided by the 39.18, and so your margin of error is roughly plus or minus 0.026, or you could also say 2.6%. Okay, so remember, going back and forth between decimals and percents. So the margin of error is about 2.6%, and these are all going to be estimates. They're not going to be exact, and that's going to be okay. All right. Now, what we want then is, so we said 48% of all people prefer brand A. So what percent? What interval is likely to actually contain the exact percent of people who really do prefer brand A? Because we have a margin of error of 2.6%, what we're going to do is we're going to take, and now I've done it already because I changed it to a percent. Make sure that when you're doing this, you're dealing with either percents or decimals. Don't get confused and match up decimals and percents, okay? So our margin of error is plus or minus 0.026 or 2.6%. Either of those is a correct answer. Now, and we usually just leave the margin of error as a decimal, but not always. So now what we want is, we want to say, well, the interval is if the margin of error is oops, I forgot the plus or minus though. If the margin of error is plus or minus 2.6%, that means that it might not be exactly 48% that really do prefer it. It could be 2.6% less. So you would take the 48% minus 48%. You could be minus 2.6%. Which would equal, what is that, 45, 48, 47, 46, 45, 45.4%. But it could be 2.6% more than 48%. So we also have to take 48% plus 2.6%. So it could be 48, 49, 50.6%. So our interval is 45.4 to 50.6%. So that's the interval, and what that means is the actual percent of people who prefer brand A is somewhere between 45.4% and 50.6%. All right, so the 48% is close to reality, but we've got a margin of error. And sometimes you'll hear that often with a margin of error of, and the larger sample size they took in their survey, then the smaller that margin of error will be. And so that's a better survey. All right, so now if I have a poll, and in this poll, a state legislator is polling to determine if people want to increase their property tax for highway improvements. And so if the margin of error is plus or minus 3%, I want to know how many people were surveyed, okay? So if we have the margin of error, then we can figure out, well, how big was their sample set? And what you're going to do is this. We know that, remember, our formula is plus or minus 1 over the square root of our set. So our 1 over square root of n, that's going to be our formula. All right? And the n, though, is, and before it was easy. We just plugged in n and we solved it. We don't have the n. That's what we're looking for. Well, we can do that. You can solve for x. So 3% is our margin of error. So when we did this computation, we got 3%, which is 0.03. So now just solve for n. So you're going to multiply both sides by the square root of n. And then you're going to divide, n, 1. So that leaves 1 here. So 1 equals 0.03 square root of n. So you're going to divide by 0.03. And 1 divided by 0.03 is 33.3. And now be careful not to say, oh, 33.3, that's how many people. 33.3 equals the square root of n. So to find out what n is, you're going to have to square both sides. And 33.33 squared is 1,111. So the sample size that state legislator called to tell you that, oh yeah, everybody wants their taxes increased, was 1,111 people if their margin of error is 3%. And I'm going to go once again and make sure that you can see. Oh yes, I'm always embarrassed when it's down by my knees and you can't see it. Okay, that was a super duper short video also. So you know what? Guess what? I might put the two together. You just never know. So the margin of error is plus or minus 1 over the square root of the sample size. Don't forget that you have to add and subtract it to get that interval to know what is the actual percent of your answers. All right. See you next time.